Good day, class. Again, this is your Sir Jerome, and I'll be teaching you again our next lesson for today. But before that, so I have here a picture of a family. What do you think are things you need to do in order for you to have a happy family? You guys. Of course, family needs bonding. Of course, we need bonding together. Next is, of course, you need also sharing. It's like these two kids. They share something with each other. You have to share, or sharing is one of the we need to have in order to have a happy family. Now, just like a family, of course, chemical bonding needs sharing or bonding. So what is a chemical bonding? So atoms or ions are held together in molecules or compounds by chemical bonds. So we have two types of chemical bonding. First, we have ionic bonding and covalent bonding. Now, so from the family, sharing or bonding, so these types of chemical also needs those things. First, what's ionic bonding? So ionic bonding, this type of bond involves complete transfer of electron. Ionic bonding will take place between metal and non-metals. Again, for ionic bonding, this type of bond involves complete transfer of electrons. And it takes place between metal and non-metal. So what are metals in the periodic table? So these are from group 1 up to 3 or 4. And those non-metals are from 5 to 8. So metal loses electrons to form cations. So when we say cation, this is ions, or ions are positively charged. So non-metal gains electrons to form an ion. So say an ion, it is a negative ion. So the electrostatic attraction is the attraction between atoms that have opposite charges and holds the atom together in ionic bonds. So again, so in bonding by transfer of electron, that is ionic bond, and usually occur metal to non-metals. And one of the things you have to consider or to remember to know if the given compounds, when we say compound, it composed of two or more elements. And we say pure, that just like pure substance or element, that is composed of only one element or substance. When we say compound, two or more elements combined as one. So when we say electronegativity, from your periodic table, you can get it and get the difference of their electronegativity. And if the electronegativity difference of the two elements is greater than 1.9, it means the given compound is ionic bond, or ionic bonding is the bonding or the type of bond of the compounds. Next, just like, here's the example, the bonding by transfer of electrons, just like the sodium loses one electron, with my S, to form cation, and the sodium. So when they combine, the sodium and fluorine forming as one or as compound, so it becomes sodium fluoride. And as you can see, the electronegativity difference from fluorine is 4.0 and sodium is 0.9, and the electronegativity difference is 3.1. It means that is greater than 1.9. So again, this type of bond is ionic. So non-metal gains electrons to form an ion. That is transfer of electrons. Okay? And the sodium loses electrons because it is a metal. Usually metal loses electrons, and to attain stability, and of course non-metal gains electrons from the metals to form as one and to become stable. So one of the reason or the purpose of transferring or sharing of electrons is to attain stability. So just like the family, they need to share or bond. So of course in chemical bonding, they need to share or attract or to gain or lose electron to attain stability. Now, next type is covalent bonding or covalent bonding. So this type of bonding formed between atoms due to the sharing of electrons to attain stability. Generally, it occurs when non-metal to non-metal form. So unlike the ionic bonding is a transfer of electrons, while covalent bonding, the word is sharing. Okay? Just like the hydrogen atom and fluorine atom. I'll give you an example. So, but in this covalent, although this is a sharing of electrons, it has two types. First, polar covalent. This polar covalent, the first type of covalent bonding, involves unequal sharing of electrons. These electrons are called the valence electrons. Now, electronegativity difference is less than 1.9. Of course, that is a polar covalent, equal sharing of electrons or unequal sharing of electrons. And as you can see, it has an unequal sharing of electrons. And the electronegativity difference is less than 1.9. They occur usually both non-metals. Unlike ionic bonding, it occurs metal to non-metal. So while covalent bonding occurs when non-metals combine. Okay, another type of covalent bonding is non-polar. When we say non-polar, it is the equal sharing of electrons. Unlike polar covalent, it is unequal sharing. But this non-polar involves equal sharing of electrons, and usually the electronegativity difference is equal to 0.4 or less. Example, we have hydrogen or two hydrogen atoms. When we say two hydrogen atoms, they have the same electronegativity, and they are called diatomic, diatomic particles or elements or compounds, diatomic. Now, so we have two types, covalent and incovalent, polar and non-polar. And we say polar, it is involved or involves unequal sharing of electrons. Usually occur non-metal to non-metal, and usually the electronegativity difference is greater than 1.9. But another type is non-polar, also is a type of covalent bond, but it is involved equal sharing of electrons, and usually the electronegativity difference is equal to 0.4 or less or 0. Now, so look at the picture of non-polar bonds in an oxygen. We say diatomics, they have the same element. That's why diatomic. So if we can get the difference of these two elements, of course they have the same electronegativity, therefore the electronegativity will be 0. That's why that is less 0.4 or 0. That is a non-polar. Non-polar electrons are shared equally, just like the joint bank account. If you have your children or child, your son, or if you have daughter, sure, if you're already get married, of course, you and your partner, and you shared equally and that's for your children. Okay? So here are the things that you need to answer, but I hope you understand, guys. Thank you, and that will be your assignment. Identify the types of chemical bond and a given compounds and its electronegativity. Thank you. It's your Sir Jerome. Good day.